Good afternoon, everyone, and welcome to our webinar, Training Models and Those Who Write Them. Before I pass it over to our speaker, I wanted to take a quick minute to go over what we do here at Fierce Software. Fierce Software is a small, women-owned, value-added reseller. We specialize in enterprise open source software, market-leading DevOps capabilities, and secure data platforms for our public sector customers. Our unique reseller perspective helps us understand your goals and technology challenges, allowing us to offer solutions from our extensive portfolio instead of just a single vendor approach. We set ourselves apart in the reseller market by consistently delivering on our core capabilities. We are an innovation broker to leading technologies, getting our customers access to the smartest people and the best technology available. We are a license manager, streamlining customer fulfillment and reducing administrative burdens. Our focus is on customer success, ensuring technical support through vendor-trained and certified professional services. We also provide customer enablement by delivering workshops, webinars like this one, and hands-on events to educate our customers about new features to enhance their team's capabilities. At Fierce Software, we are dedicated to supporting your Red Hat training journey, and we can offer discounted training rates off MSRP. After this session, we would be happy to provide a quote tailored to your needs or any extra information. If you have any questions at any point, go ahead and leave them in the chat, and we will be sure to answer them. I'm going to go ahead and stop sharing my screen, and you can go ahead and take things away, Wes.
Awesome. Thank you very much, Jody. I appreciate that. I will share my screen here. Looks like I have to send a request to you to do that. No problem. Magic of television, everybody. Great. Can you all see my screen okay? Everybody hear
Yep.
me? Yep, see me? Good. Awesome. All right. Well, welcome everybody. Thank you, Jody, for that introduction. As you mentioned, we're here to talk about Red Hat's position in the AI landscape. So I actually just retitled this webinar, Training Models and Those Who Train Them, to be a little bit more reflective of the material that we're going to cover today, and that's really exciting. So we'll give kind of a brief overview about how Red Hat training fits into the overall AI ML picture. We'll define all that in just a second. As Jody mentioned, my name is Wes Urquhart. I'm a solution architect in the Red Hat North America Training and Certification team. So really excited to be here to talk with you today. A brief agenda of what we're going to go over. We'll set the stage. Why are we here? What are we going to cover? What's this journey going to entail over the next hour or so? What is this AI/ML thing, right? We'll break it down a bit further. Folks love to throw out AI, machine learning, Gen AI for these generous terms for whatever reason. And we're going to really kind of decouple those, take those apart, deconstruct it, and kind of refine our scope of what we're really talking about here. And then, what's Red Hat's approach to AI/ML? What does Red Hat do in this space? Where are we trying to fit? Where can we help you in your business and you just as the person trying to explore AI? And then, of course, where training fits into the picture. How can you learn more about some of these tools that we talked about today? We'll wrap and review, just kind of some closing remarks and then open discussion. I also have a slot for a live demo in here toward the end if we have time. So definitely look forward to that if we kind of get there. Really excited to get to that point. As always, please feel free to post questions in the chat or the Q&A, whichever feature works best for you. I'll kind of keep that up throughout the presentation to keep an eye on it. But my co-solution architect, senior solution architect in the Red Hat training team, Rob Locke, is also here with me in the chat answering those questions. So you may see his name pop up as well, and that would be why you see him. So thank you, Rob, for being here to talk to those questions. And with that, we will move right on ahead. So why are we here? Great question. I ask myself every morning. So, in a more serious note, you're probably hearing a lot about artificial intelligence and machine learning and companies that are playing in this space, and things like DeepSeek, NVIDIA, and hopefully Red Hat and IBM as well. So what we're going to do is cover a brief and very high-level overview of artificial intelligence and machine learning as concepts. You can get doctorates in these things and get really deep in the weeds. We're not going to go that far today. We're just going to kind of set the stage for working definitions for this conversation today. And then we'll talk about where Red Hat fits in, of course, as we want to, and then how training can kind of assist you learning your next steps of the way for this kind of journey here. So, brief disclaimer. This sounds different than a Red Hat AI presentation I heard 6 months ago, 12 months ago, 24 months ago. Why is that? You changed your message. That's accurate. I gave a similar version of this presentation not all that long ago, and it would be entirely different today if you saw it from me 6 months ago. So if you did, stick around. There's going to be a lot more different information. And why is that? Well, the artificial intelligence space evolves really, really quickly. It's very fast moving, and Red Hat reacts in kind, right? We have a lot of grand plans, a lot of strategic vision, and a lot of goals in this space, and that requires quick updates, quick changes, and quick pace towards developing these tools. So keep that in mind in general in the artificial intelligence space, but watch Red Hat for updates on a regular basis. And in this case, you're going to see the latest and greatest. And how do you know that you have the latest information? Well, I'm doing my best as a presenter here to keep pulse on the latest updates from Red Hat in terms of AI, attending sessions with our experts from the business unit as well as our services team, and really kind of making sure we're giving you the latest and greatest information, at least as of today's webinar, which is live on February 27th, 2025. So moving right on ahead, let's talk about artificial intelligence and machine learning in the more kind of broad scheme, more definitions. Brief warning, this will almost certainly be an oversimplified set of explanations. It certainly will be. Seek additional resources if you want more nuanced technical explanations. We're not striving to make you experts in these subject areas here today. We're just trying to make sure we all understand and are on the same page as we move ahead to explain where Red Hat fits into this space and where you can learn more and some of the cool stuff you can do with it. Let's start with the artificial intelligence portion of this. What is AI? You'll see the umbrella icon I have there on the left. I love to call it an umbrella term that encompasses a lot of different fields and technologies, a lot of different disciplines. I have seen many different definitions. It's defined many different ways. Folks have different opinions here, but my most generic attempt to define it is any computer that exhibits human-like, that's key, human-like intelligence and thoughts. It's been around for some form or fashion for a very, very long time. And we're going to talk a bit more about the different spaces. A lot of times we class AI into either predictive or generative. A lot of the buzz right now is on generative. We'll talk about that in a second. But some other terms you may hear under this overall umbrella of artificial intelligence are things like search algorithms. My algorithm is listening to me, whether it be on a social media platform or just on a search engine, or maybe just in your email inbox, even when you get promotions. Those are search algorithms, checking to see what it is you're looking for and kind of guiding you towards things it thinks you're going to want to click on and engage with. Rules-based systems. These have been around a really long time. If you've ever worked with a chatbot or a phone tree or anything of that nature, that is a form of artificial intelligence, predictive form of artificial intelligence when we talk about predictive versus generative. It's a set of rules that say, hey, we think if you're responding this to this question, then we want to send you these options and then these options. Think basic kind of triaging on a phone with, an airline maybe or a hotel chain, just something where you're working through an automated agent. And then, of course, machine learning. This is where we get into the generative portion of the conversation, where we're actually, doing a lot of deeper techniques. And we're going to talk about machine learning here in just a second. Machine learning will always be some form of artificial intelligence, but artificial intelligence does not have to use a discipline of machine learning. So whenever you see AI/ML, note that they are not the same thing. They are not interchangeable. Machine learning is a subset, a discipline of artificial intelligence, and it typically falls on the generative side of artificial intelligence. Other pieces are more predictive, things like rules-based systems. Some search algorithms, so that's iffy, it kind of depends, are more in the predictive space. And those have been around for a very long time. Decades. Folks have been using that for forecasting in places like financial markets, as well as your carts at Amazon, those sorts of places. That form of AI has been around a long time. A lot of the buzz right now is around generative AI, which we'll talk in more depth here as we go. If you're so inclined, would love to hear some examples of where you see flavors of artificial intelligence in your day-to-day life. Feel free to pop it in the chat, pop it in the QA. We'll kind of keep an eye on that, but would definitely be curious to see where you think you see artificial intelligence on a regular basis. Can be predictive, can be generative. Doesn't really matter. Really curious to hear what your examples might be. Some that I immediately think of are my Made for You playlists on Spotify. I love those. I love trying to find new music. That's it, predicting or kind of thinking through what I would like based on other music selections I've made. Okay. So let's dig into the machine learning portion, the portion under the umbrella of artificial intelligence. So the definition I'm going to use here is teaching a computer to respond to queries of all kinds by, quote, training it on huge volumes of sample data to the point where it learns how it should respond to those queries. Keep in mind here, we're not saying human behavior. There's a lot of debate in the artificial intelligence space about when you'll achieve certain deep intelligence or something that is more of a human agent with an artificial intelligence. And that's something some folks are chasing. And some folks are having questions around ethics in that certain manner, or what viewed as sentient thought versus something that is being predicted based on probabilities and different training aspects. We're not going to get into that portion of the discussion today. We'll leave that to someone smarter than me. But in this case, we're going to define machine learning this way. So if we think about machine learning and how it works, you have a base model, a theory, a thing you've trained to say, hey, this model is something that I think can, at its core, respond to queries of a certain kind. A lot of times you'll see these models as striped for doing things like chat. So think there's a Granite chat flavor of model. Also, GPT is a flavor of chat model as well. You might also see it as images, where you're feeding images to it and it will create, either identify them, or you can ask it for it to create one and it will create one as well. Audio as well, also just various other very specific forms of models that can do things. But the base model is built to do those things and then to be trained. So what you want to do is feed the model a lot of data. Example here is Amazon orders from thousands of people. You want to feed it lots of data so it can learn. There are a couple of different ways to do that, and we'll talk about that in just a second. You want to grade the results. Did it succeed or did it fail in terms of identifying the data the way you wanted it to? Thinking of invoices, for example, and maybe ones that are of a certain dollar amount or are delinquent in a certain way, or maybe fraud alerts. This is an example of fraud and where we'd want to send an alert versus not. Things of that nature. You want it to know how it did, and there's a couple of different ways to do that. Then the model will learn. We'll say, oh, okay, I learned the good and the bad here. And then it will go again. And then it will go again. And some of this can be done with synthetic data as well. So we'll definitely give that a look here in a little bit. But as you go and as you feed it more and more data, the model keeps learning and gets better and gets better. That's the theory here. And there's a lot of science into how much teaching you can do before you get plateauing and how much you can kind of get drift or maybe regression. But in general, without going into those deep ends of the pool, this is the flow. This is the cycle. You have a base model, a theory, and then you train it on data until it gets really, really good at doing the thing you want it to do. The harder it is, the more things you want it to do, the harder it can be to train. Keep that in mind. But that feedback loop will eventually improve, in this case, let's say Amazon's metrics for predicting what should go in your cart, where your next order should be. If you've ever thought that it's gotten better at that over the years, you're not wrong. I believe the same thing. And that's just because it's got more time, it's got more practice. These tools get better the more they are used and the more they are worked with and the more they are developed. Brief aside, I mentioned we talk about different ways to train a model. A lot of different, if you think about training, there's two separate general categories that folks will broadly put training into, and it's supervised versus unsupervised, which refers to how the training data is fed and presented into the system. One option here is supervised, where you say, hey, I've got 6,000 bank alerts, and I happen to know that 10% of them, so in this case, that's 600, are marked as fraudulent, and I pre-mark them. I do the work ahead of time. I say, hey, model, here are 6,000 pieces of data, objects. These 600 are fraudulent. These 5,400, had to do math on the fly, was told there would be no math, are not. And it's up to you to determine why, but you already know the answers ahead of time. So understand these. This is my training for you. That requires someone to go in and mark all of that data ahead of time. It is very time consuming. It is a lot of data cleansing. It is a lot of setup work for someone who is maybe a data scientist, for example, is a role that might do this sort of thing. Unsupervised is a little bit different. The data is unlabeled and the model learns by making guesses. So you just feed it those 6,000 unmarked alerts or examples, and it's just got to learn for itself. I think this is fraudulent and this is not, and here's my logic as to why. And then you can sort of grade it as you go based on, hey, here's another piece of data. Did you get it? Did you not? Let me test it. And you give it feedback that way over time. The supervised model tends to provide for quicker results, but the unsupervised model of training tends to provide for more creative thought processes that humans may not have considered, or those training the model may not have considered in ways to deduce things that may never have gone into the model in the first place. It may result in more robust understanding of what they're looking at, but it does take longer. It takes more computing, takes a lot more data too. So keep that in mind. And I said, can anyone see any inherent advantages or disadvantages in either? I just spilled the beans on that, but if anyone has any other ones, I would love to see it in chat or in the Q&A. I'm not seeing anything over there right now. Nope. So that's okay. We will continue to roll on. If you've got any questions, any comments, any thoughts, if you just want to participate in the conversation, say that's exciting, please feel free to throw it in the chat or the Q&A. That's what we're here for. Okay, One other thing to note about this can require lots of time, lots of data, lots of effort, and lots of computing and can be highly resource intensive. If you think about just having to pass all of this data through the system and having a model having to read every piece and make a distinction, make a judgment, and actually formalize those grades and give you feedback on why it did so, that's a lot of thinking. That's a lot of having a computer do processing. When we talk about needing higher end computing resources, this is what we're talking about. We're talking about it running on, and 6,000 is really a very, very, very small data set in the grand schemes of things. When we're talking about billions and billions of tokens things have been trained on. So keep that in mind as you think about where that computing is coming from and why it's so important these days that people are looking for those GPUs, for example. So what do I do when I put it together? You get AI/ML, right? So you get artificial intelligence applications that are driven and built on machine learning, right? So at the end of the day, these are all applications. You can't really make use of a model that has been trained without something on top of it that helps you interact with it. Be that a chatbot, be it something where it's looking through data like an API to query, call different data results and different hooks to sort of have it pass through, to be a check or a minus on fraudulent, for example, fraud alerts. It's got to be useful. There's got to be some sort of application interaction with it. But it's a lot of computing and it's a lot of data to run these. So let's talk about what it takes to do this. All of these logos that you see here are examples of projects, open source technologies, where you can use a different tool in a different part of this cycle. It's a lot to wrangle, right? If you think of this as just a set of tools for your AI/ML workflow here, for creating sample data, for cleansing that data, for serving an inference server like VLM there, which is a new addition if you've not seen this presentation before, monitoring it, making sure nothing is drifting, making sure configuration is the same, making sure nobody is kind of putting in conflicting inputs and conflicting training. You need Python code packages, you need Jupyter notebooks, you need PyTorch, Starburst, all of these different things. Oh, and by the way, you've got the model underneath that's very large to begin with. So this is a lot going on. And for the average IT department, it is really hard to wrangle all of these tools together, keep them in check, make sure they're secure and compliant, and make sure that everything is interconnected and working together, and keep everything patched on a one-off basis. It is a lot to do. And candidly, a lot of this starts with data scientists who may not have that IT discipline in their background and may not understand those pieces and parts where you have to keep things up to date and keep things working. And it requires some collaboration with your operations folks, with your engineering departments to make sure that on an enterprise scale, you can do this safely in a secure fashion and keep it stable and make it work, right? So where does Red Hat fit into that space? Well, I said open source. I said lots of different products. So ring the OpenShift bell, where we're able to take all of these different open source projects and curate what we believe to be the best selection of, hey, we think this infrastructure and ecosystem will work best for you to run your artificial intelligence operations, data, training, all of that good stuff. And we're going to call it the Red Hat AI platform, or Red Hat AI for short, both for generative and predictive AI. And as you can expect with Red Hat, our value proposition for all of our products is we want you to be able to run them anywhere flexibly with an open hybrid cloud model. Think can be physical, can be virtualized, can be in a public cloud, can be in private cloud, out on the edge. Whatever you need, we're trying to be there for you wherever you are. Meet customers where you are in your journey. And you'll notice here within the Red Hat AI portfolio, you've got RHEL AI or Red Hat Enterprise Linux AI and OpenShift AI. Let's talk about what kind of fits into both of these products here. So RHEL AI is a foundation model platform for developing, testing, and running the Granite family of large language models. Talk about Granite in just a minute. We'll kind of put that to the side. We've got a separate conversation on it, or that family, I should say. What we're doing here is we're bringing a bunch of different tooling together that we believe are necessary for developing, training, testing, and confirming AI tools using machine learning methods. And you can also, of course, use predictive workloads here as well. But for the most part, this is meant to test enterprise grade AI applications, right? That's the idea. We'll break that down a little bit more in just a second. OpenShift AI is there to help you scale it. Just like OpenShift is there to help you scale your other application workloads to make sure that folks can access an application from anywhere with very little downtime. It can scale, it can be secure, and you can mix your footprints for, part of your private cloud deployment or part of it on public cloud or part of it on premise. And you can have that flexibility to use up your entire ecosystem there. That's the same idea with AI, OpenShift AI. Just think about it for AI workloads instead, both predictive and generative. You can bring your own model if you'd like to. You don't have to use ours. You can do this on OpenShift AI, which is an operator that's installed on top of OpenShift that gives you access to these suite of tools that help you manage your AI ecosystem. You also include RHEL AI entitlements with OpenShift AI, which includes the Granite family of models and some other really cool stuff. We'll get to that in a second. One other thing I want to point out here is our AI portfolio isn't limited to the Red Hat AI platform. That's a large component, and it's a very core to what we'll be doing in the AI space with RHEL AI and OpenShift AI, which we're going to dig into here in just a second. But we also have an AI-enabled portfolio and AI-enabled apps. So when you think about other ways that AI can help you and your business, we want to enable our tools, RHEL, OpenShift, and Ansible, with AI assistance to help you do things like write playbooks with Ansible Lightspeed or understand what patches you might need to make in RHEL. That's something that's there as well. And of course, any other AI-enabled apps, we want to be there to help you run those and make sure they work just as well with OpenShift AI or not in this case. So keep that in mind. And all of it, again, built on that same open hybrid cloud platform stack that you know and love from Red Hat. Let's talk a bit more about the Red Hat AI portfolio, and let's break down kind of the step by step. Something you haven't heard from me yet is InstructLab. And I'm going to break that down in just a second in more detail and kind of explain it. But if you want to experiment with our tooling for artificial intelligence, and if you want to train your first model, you can go to the github.com/instructlab page, and you can learn how to do that right now. It's incredibly approachable. It's incredibly user-friendly, I should say, as a way to train a model. And we're going to talk about how it does that and why it's different than what else is available in this space today, and how we're enabling folks that may not be data scientists to get their hands on these tools. So we'll come back to InstructLab in just a second. Oh, and by the way, it's open source, as is all of this. RHEL AI, we take that theory that you might have developed using InstructLab on a more localized scale on your laptop, and we make it bigger. We say, okay, let's make this a test of production grade, a proof of concept, so to speak, of what you would do with a production grade model, AI application, inference server, and let's understand how this works. Let's see if it will work on a production scale in a test using RHEL AI. And again, we're looking at server or VM here. So one step up. And then OpenShift AI is scaling it. We've proved that concept. We've proved the idea that this will work for our business. Now we want everyone to have access to it. We want to make sure it's stable, and we want to treat it like any other modern application that we run on Kubernetes. Done. No problem. So let's talk about InstructLab. I love to use analogies. So here's one for you. Let's say you are picking up baking as a hobby, right? You're saying, I love the bread that I get from that French bakery down the street, and I'd really love to figure out if I could replicate it myself at home. Just as something I want to do. When you've been to that French bakery, though, you notice that the chefs obviously are very well trained. They've got a large background in this. They are years of experience in it, and a lot of things come second nature. They also have access to tools that you wouldn't have any dream of having in your home. Fancy bread ovens that have different humidifier options to make sure that the bread is both moist but also gets a crust, because there's a pizza stone embedded into the bottom of this very large oven with moisture coming through somehow, and it doesn't seem like it's anything that you can replicate at home on that scale. That tool is not available to you. It's too expensive, it's too big. It just doesn't make any sense to have that single purpose tool in your house. So, can you still replicate French baked bread professionally? That model, can you replicate that at home using different methods? Yeah, you can. For any of the bakers among us, you'll know that there's a very large community around home baking, and there are different ways to create a product that works for you. And at home, you can use the tools and methods available to you. Instead of having this big one-size-fits-all oven, you can use a Dutch oven and a regular oven and kind of make it a double oven and make yourself a very nice loaf of bread that works great for one specific purpose, right? I want this thing to do this loaf of bread in this recipe for me, and it works just as well. And I can put it up against the French bakery, and sometimes I'm even going to prefer mine over the French bakery because what I've done is more bespoke to exactly what I want to be eating. It's a perfect use case for exactly what I want to be doing. And I was able to do it at home without years of formal training, without very expensive tooling. I could just do it. And I was able to find those methods online fairly easily through the community and with things that I might have already had at home. We can apply this to model training, data scientists, and hobbyist developers. So if we take that intimidating world and we make it the land of artificial intelligence and training models, historically, it has been a high barrier to entry to train a model. You had to be a data scientist. You have to know a coding language, probably Python in this case. You have to understand how to use the various tools available to you to train that model, probably Jupyter notebooks and a lot of plugins within. You also have to understand how to interact with that model such that you can read the outputs that you're getting in these very dense numbers and understand all these different weights and understand what they all mean and how you can be tuning this model. And it gets very confusing very quickly. It's very disparate. It's very in the weeds. It's very development oriented. It's very data science oriented. It's very statistically oriented. If you think data science, it's also data as a science. There's a lot of statistics involved there too, right? And that can be really overwhelming, even for someone with a familiarity of software development. It might just not make sense, or infrastructure development, or any kind of hobbyist in IT. You might say, hey, I get the general idea of what you're doing here, but it's such a high barrier to entry. And by the way, I don't have that fancy hardware you have either. I can't experiment with this at my home because I just got a laptop. Yes, you can. InstructLab is the hobbyist baker's answer to the fancy French ovens and fancy French bakeries. InstructLab is there to help the hobbyists and take those hobbyists and make them as productive as some of those data scientists in some cases for their use case. If you've ever heard Matt Hicks, our CEO, talk about our strategy, or the IBM CEO talk about the strategy that we're employing with AI, it's all about smaller, purpose-built models meant to do a specific thing on a smaller footprint with a very targeted training regimen. This is what we mean. You can take InstructLab and the tooling it uses, the methodology it uses to train models, the lab methodology, which is a language alignment for chatbots, I think large language alignment for chatbots. You can fill out a file. It is a human readable file. It is in YAML. It is easy enough. You say, I have a sample document. I want to take and copy and paste a couple of elements of that document into a file. And then I want to pose questions about that text, write answers to those questions. I give that to the model using InstructLab. It trains it, develops synthetic data to replicate exactly what you've done. And now you've trained a model with very little data science know-how. You can do that. I'm in the process of doing that, and I'm not a data scientist. I've done it in mock environments before. And you can do it on slightly smaller hardware, which is also great. It might take a little bit longer, but it's doable. You can experiment with this on your laptop. This is doing it the home baker way. It's different, but it works. Bonus, InstructLab is open source, and the documentation is great. GitHub.com/InstructLab is out there. The community is very active. It is a way for everybody to contribute to the world of AI. It's a way to democratize AI. Okay, so InstructLab is a way to train a model. What model do we use? Granite, of course, the Granite family of models. Now, it's a strong performer in the Forrester Wave AI Foundation models for language, which is awesome. Different benchmarks, depending on when you take snapshots, will say different open source models are doing better at any given time. Right now, people are just kind of improving, and it's a great thing. Granite is open source. Open source license large language models distributed under the Apache 2.0 license, just like any other Red Hat products, right? Our open source foundation is key here. This is doing AI open source. Purpose built for business. I mentioned the smaller models piece. We don't believe that there is a one model to rule them all that will work for business. Having one model that does everything for you is making something too bulky and trying to make one solution that does it for every single thing. Why not train a model that's meant to do a specific thing and do it really, really well? read your insurance claims, understand your specific fraud cases, understand your specific feedback that you get from survey results from your customers and what you should do to act on them. Why not make those purpose built? And why not have your subject matter experts from your business have the ability to contribute to that training using InstructLab? Indemnification too. Red Hat will indemnify customers for IP claims, right? We're standing behind that. There are some limitations here in terms of when you introduce your own data versus what we back, but a lot of folks right now from a legal point of view are not sure whether base models out there are using legal data, are there and protected, and scaring folks from trying and scaring folks from understandably embracing full-heartedly some of these different models. Well, we're here to stand by you and indemnify you for those IP claims using the Granite family of models. It's a big deal, right? InstructLab, Granite, and Linux are a dynamic open source trio, which is why we put them together in RHEL AI. If we go all the way back to talk about RHEL AI and what that stack is, the core components of it are Linux, which is, of course, core to all of this. The Granite family of models, or the access to them as a base to train, and InstructLab, which gives you the tooling in order to train that model on your exact use case to do exactly what you want to do, and also some inference server elements there too, like VLM, and some other really cool tools are within RHEL AI. And then you take those components that you used on RHEL AI and you scale them using OpenShift AI. Really, really cool stuff. Oh, and by the way, we're not done yet. I encourage all of you to go look into Neural Magic and look into the Red Hat acquisition of Neural Magic. If you put two and two together like I do, you'll be just as excited as I am that we're partnering with the great people from Neural Magic to bring their awesome work in the open source community, specifically the VLM project and their work on that inferencing server and their work on optimizing open source models into Red Hat's technology stack. Keep an eye out for more of that. Comes roughly later this year. I shouldn't tell you when or what, but keep an eye out. Like I mentioned at the very beginning of this, AI moves fast, and Red Hat is moving fast to keep up with that AI trend and everything that's the latest and greatest. This is part of that. So just keep an eye out for updates that revolve around Neural Magic and Red Hat together. It's really exciting stuff. I wish I could share more with you, but at this point, I'm not at liberty to do so. So, Red Hat AI, that's the stack. That's the idea. Open sourcing AI, democratizing it so that you can get your hands on it. You can play with it today. You can make a difference with it. You don't need necessarily as much hardware, as intensive hardware. You can get to a very purpose-built solution using tools that make sense that are familiar to you. And if you're already a Linux user or a RHEL customer, or if you're already an OpenShift customer or a Kubernetes user, you can do it in a way that makes sense to you and makes sense for your business without very much change, right? So where does training fit into the overall puzzle? If you want to learn more, glad you asked. So Red Hat Training offers a variety of different ways to consume enablement to meet you where you are. So on the left here, you've got live instructor-led training options. If you want to take a class with an instructor, you can do that however best works for you. Be that virtually on an open enrollment calendar where you sign up and you take it with whoever else signs up for that class in the world, or with a private class, if you want to have an instructor come to your facility or meet with just your team over a Zoom bridge, for example, can certainly do that as well. If you want to take a class with an instructor, that's a thing we can offer you, and it's a thing that we are increasingly seeing more people move back towards. The pandemic sort of moved everything to a virtual environment, and slowly a lot of people are recognizing the benefits of doing things in person again. And one of those things is training, bringing your teams together that may have been hired from disparate locations and remote capacities over the course of the pandemic and the recovery effort, bringing them together for a team building exercise and to learn and to talk to one another is a really valuable exercise. On the other side is self-paced, which is also great for a variety of reasons. You can take a class, the same that we teach with an instructor, on your own time, using a textbook, videos that are recorded for the self-paced audience, no grainy back of the classroom, accounting 101 footage from college, in a studio meant for you, lab environments that we host that you can play with that are effectively a sandbox for you to go play with these technologies and tools. And you can do this either on a one-off basis, class by class, or with the Red Hat Learning subscription, which is 12 months of access to all the training that is available self-paced with all of that I mentioned, textbooks, lab environments, all that good stuff, videos recorded just for you, plus certification exams, depending on what tier of the subscription you purchase, if you're interested in certification. The other option is to blend the best of both worlds, which with our RHLS premium tier. So you get everything from the self-paced tooling, right? All that good stuff. Plus, if you get the premium tier, the top tier of RHLS, you have a calendar that is just for the RHLS premium audience where you can go and sign up for live classes with an instructor. Virtually, you sign up and you take it and you can actually sit in a class just like you would if you were to go take a class virtually with an instructor on a one-off basis. So it kind of blends the best of both worlds there. Really, really great tool set. Ultimately, there's a lot of different options here. Work with your Red Hat and Fierce account representation as it relates to training to kind of figure out what the best blended option is for you of self-paced and instructor-led training. Let's talk about what that training entails. So the world of AI is moving very quickly. And like I mentioned, Red Hat is no exception here. So this training is accurate as of today, may not be accurate in 6 months. Who knows? Or even sooner than that. But this is what we have to work with now. So a couple of things, and we're actually going to show, it looks like we're going to have time for a demo. So really excited about that. And what we're going to demo is our RHLS exclusives here, running models locally with Podman Desktop AI Lab, and then Podman AI Lab recipes with Podman Desktop. These are something new called lessons in the Red Hat Learning subscription that is exclusive to the Learning subscription, where they're just small bite-sized pieces of material that may not have fit directly into a class, but we think is worthy of a couple of chapters to kind of show you, hey, this is what we're talking about here. Here's the book. Let's talk through it. Let's have a couple of exercises. Let's have a lab, and you can be on your way. A smaller bite-sized chunk of learning that's available to you in the Learning subscription. In this case, you're focusing on Podman Desktop AI Lab. What is Podman Desktop? It is a way to run containers and containerized applications on your laptop with a graphical user interface, no command line needed. You can do it obviously on Linux. You can do it on Mac. You can do it on Windows too. And the AI Lab extension, as a part of Podman Desktop, helps you spin up AI chatbots and AI applications really quick to test your theories, to test models, to play around, to get an idea for artificial intelligence, just to get your hands on the technology. And that's what we're going to do here in just a second. Okay, moving on down, something called our technical overview portfolio in the gray boxes here. We have got two of those on this slide. So one is the Red Hat Enterprise Linux AI Technical Overview, or RHEL AI Technical Overview, released relatively recently. You can go sign up for this on training.redhat.com or through the co-branded links with Fierce. And you can go see a longer overview than we did today just on RHEL AI with some demos. So a couple hours worth of, I think this one's like an hour's worth of videos just to kind of get a better grasp on what are we doing with RHEL AI. Soon, we will have a course on RHEL AI, develop, test, and run the Granite family of large language models with Red Hat Enterprise Linux AI. So a hands-on course where you'll actually learn how to do those things with Red Hat training. Coming soon. Keep an eye out for that one. And then we have a technical overview on OpenShift AI, of course, to give you a better lay of the land of what OpenShift AI is and how it fits, kind of more in-depth there as well with some demos. And then a course on OpenShift AI that is available now, where we teach you things like an overview of what OpenShift AI is, getting hands-on with it, and then creating things like your first data science project with an OpenShift AI, understanding how to administer OpenShift AI. Someone's got to keep the lights on, how to run data science pipelines, how to deploy a model, how to train a model on OpenShift AI. And of course, there's a certification there available as well with our OpenShift AI course. It kind of goes along with it, follows along. Okay, time does allow for a brief demo, so let's do it. So I'm going to check the chat and the Q&A just to make sure we have nothing in there. I don't see anything here. Cool, so we'll do a demo. So here's what I'm going to do. I'm going to pop over to a learning subscription page, my learning subscription page. This is what it looks like for anyone that might not have seen it. I'm going to zoom in a little bit. And like I mentioned, we're going to spotlight one of our lessons, which is running models locally with Podman Desktop AI Lab. I'm going to open it here, and you're going to see an abstract, but you're going to see some other cool stuff at the top where we have like a duration. For those of you that may be familiar with RHLS, you would not have seen this on any of our courses. It's something we're phasing in, duration. So in this case, 1 hour and 20 minutes estimated time to complete this lesson. How many exercises are there, how many labs you have, how many quizzes, and how approachable it is. What's the difficulty level? Okay, so I'm going to go ahead and launch this. And you'll notice you get an intro, just like any other class, where we have objectives, the audience, and prerequisites. So what we're going to do here in this lesson, we're not going to do the entire thing today, just a snippet, is select the appropriate model for the desired task and available hardware by using the Podman AI Lab extension, create a service to serve inference requests for a particular model using Podman Desktop AI, inference request, chatting with the chatbot, and then consume local large language models from Podman AI playgrounds and client applications. We're not going to do all of that today, but we're going to do a snippet of it. So I'm going to fast forward here to the first guided exercise, which is running models locally. Now, a brief wrinkle. We do have a lab environment in place for this in the learning subscription that you could go launch, and you can do all of this self-contained on Red Hat infrastructure. You don't have to worry about anything, installing anything on your own machine. But I've kind of taken one extra step. I've got Podman AI Lab running locally on my Mac, and I've had it for a long time. The Podman desktop interface, as well as Podman machine running on my Mac from the command line. So I'm going to do most of this, all of it locally. I'm just going to do it a little bit differently because it's on my own computer, but I'm going to follow their steps. So in this case, you see I've got Podman running. And there's some other cool stuff you can install using Podman desktop. Again, I'm on a Mac. You can do this on a Linux or a Windows device as well, which is super nifty. So I've got it installed, right? So I'm on Podman desktop, and it wants me to click the AI Lab logo, which is the extension. I will do that. This nice little seal. Cool. And it gives you a brief overview of what you're looking at here in this extension. The recipes catalog, AI models, model serving, playgrounds, and feedback. So it's not a ton of different options here, but you can do a lot of really cool stuff within just these few different menus. So now it wants me to download a model. So on the AI Lab pane, click catalog, go to the models, and then download a model. For the sake of time, I've done this already. And I've actually downloaded the latest version of our Granite 3.1 8B Instruct GGUF model here. So an even more newer version of the model than in our course. Again, things move quickly. So in this case, I'm just going to use that edition instead. And I downloaded it a couple days ago just to save time and to play with it too, because I think it's fun. Okay, wait for it to download. And then you can open and see where the model has been saved in your pathway. So I click the folder here, and then you can't see that because it's on a different screen, but it opened up my file explorer. It's not that exciting. Okay, great. And then it wants me to create a model service. Okay, I can do that. So click create model service icon, which is there. Right, I'll update that later. It's fine. I'm going to create a service. What this is doing is it is creating a containerized service for me to run a little chat application to play with, right? So at this point now, let me go back and check. It's done, and I can open the details. And I can actually chat with this on my computer locally. And this is an example command to chat with it, which you'll notice is not incredibly user-friendly. We're going to get to a different way to do that in just a second, which is really much easier. But for the sake of this exercise, let me copy this. I'll paste it into my own terminal window, which I will pull over to a screen you can see. I'll make it bigger so you can actually see it. Great. I'll paste it, hit enter, and it's actually going to run here for just a second. My computer's a little overloaded right now. It's a little old, and I actually have a PC to refresh in, so it's going to take this a second. So we'll come back to this in a second. But what you notice here in this payload is you're saying you're a helpful assistant, and then asking what is the capital of France. And so we expect a return response in due time here. We'll come back to this. Okay, at this point, it tells you, hey, this is the response. This is really neat. And then it tells you to stop it, and tells you to inspect a couple of things, and it tells you to delete the model. I want to take this one step further. So I mentioned before that this is cool, but it's not all that user-friendly. There is a user-friendly option. I'm going to go create a playground, right? And I've already created one, but I'm going to start one from scratch here. New playground, and I can make a name. I'll call it Demo Playground. And I'm using this model, the same base model, and I'm going to create one. And now I've got it. I'm going to click into it. And you'll notice things here like, hey, I've got different settings, different ways I can sort of train and test the model with different weights, which is super neat. I can also go, hello. And now I'm just in a little chat window with this bot. And it's just running off the base model. I haven't trained this in any way to be anything different than what you can just pull down off Hugging Face. So it's available for you to do this exact same thing. All of this is completely free. Everything I'm doing, except for the learning subscription, except that, the software I'm using and the technology I'm using here is absolutely free. The models are out there for free. Podman Desktop's out there for free. You should definitely play with it. So in this case, it's told me I'm here to provide helpful, honest, and harmless responses. What would you like to talk or ask me? Now, for the magic of television, I want to show something called model bias in a very fun way. I happen to know that one of the folks at Red Hat who works very closely with the Granite project, with our associates and friends at IBM, and as well as works a lot with Instruct Lab, he is a very big Tennessee Volunteers football fan. So I said, I wonder, I wonder if the base model is trained on Tennessee football. So let me ask, tell me why the University of Tennessee football is the greatest. It gives a very robust response, right? It is accurate as well, for the most part, at least as far as I can tell. It's very thorough, very responsive, and says, hey, if I'm in debate club, this is my position as to why it is the greatest. You can tell it's been given this information. Thought to myself, I wonder if my alma mater, my North Carolina Tar Heels, who have a big game tonight, the women do, against Duke University. I'll be in Cameron Indoor Stadium for anyone else going to be there. It's going to be a great game. But I wonder, for the men's team, storied program, will it have the same information? Tell me why the University of North Carolina men's basketball program is the greatest. It looks roughly the same, but there's something very, very wrong with this. Any college basketball fan will tell you the Cameron Crazies are Duke. Cameron Indoor Stadium is Duke's stadium, our most hated rival, which it also spotlights here, most notably with Duke. It is associating that with UNC. The model has not been trained properly on Carolina basketball. It's doing its best, but it does not have nearly enough information. So now I know what I have to do in my spare time over the next week or so is contribute an InstructLab file of knowledge back into the open source InstructLab project so that it knows all the greatest facts about North Carolina and that we are not the Cameron Crazies. This I took great offense at. So anyway, this is a good point. It's a fun way to play with these. And all things aside, this is a very low stakes example of model bias, as you can tell, the person who trained it versus didn't train it versus who's been involved and not involved. But the cool part about the Granite family of models and InstructLab is it's open source. I have the power to go make this change myself in the upstream code. You don't have that same authority with other popular AI models and tools that are out there. And you can do this without a data science background entirely. That's a bit out of the scope of this webinar today in terms of how we do that, but just wanted to show you some brief ways to play with these tools. Okay, at this point, let's just wrap up here. I think I'm still sharing my screen. Yes, I am. Good. Okay, cool. At this point, just to wrap and review, machine learning is a type of AI that many are embracing for advanced application development. Red Hat offers open source solutions for everyone in your AI journey, from data scientists to developers, all the way to the operations teams. So through open source projects, community editions like InstructLab, and the Granite family of models, through to RHEL AI, through to OpenShift AI, and AI-enabled products, things like Ansible Lightspeed. We're there to help everyone from an AI-enabled point of view. And Red Hat Training is there to help everybody learn about these exciting new technologies. So with that, I wanted to leave quite a few minutes here. So we've got about 10 minutes for open discussion, for any Q&A, so anyone can ask any questions here that you might be interested in learning more about. So I will look at the chat to see if there's anything there, or the Q&A. I don't see anything in there at this point. Rob, I see you trying to drum up some interest, and I appreciate that. But at this point, I don't see a whole lot. While we're waiting on questions, I don't know, Jody, if you had anything you wanted to say kind of around Fierce, and kind of any kind of parting words or closing words, while we maybe wait for any questions to kind of roll in.
Yeah, I'll go ahead and share my screen really quick.
Yeah, I'll stop sharing here. There you go. Cool. So I'm just looking around here. Rob needling me about Duke and the Wolfpack in the chat there. Gotta love it. That's the fun of sport. Still not seeing anything in the Q&A or in the chat. Jody, back over to you. Anything, I guess, if we'll kind of filibuster for just a second, just to see if anyone's maybe furiously typing away questions or what have you. I know we're right around lunchtime, or just after lunchtime, or just before, depending on where you are in the world. So maybe getting some naps, or getting some people eating. So hopefully you listened and enjoyed it. But Jody, back over to you.
Well, thank you so much, Wes, and thank you everybody for joining us today. We will be sending out an email within the next 24 hours with the recording of this webinar, so you can reference it at any time at your convenience. And like I mentioned earlier, Fierce Software, we are dedicated to supporting your Red Hat trading journey. We offer discounted rates off of MSRP, and we'd be happy to provide you a tailored quote. So all of our contact information is on this slide. And please reach out to us and we'd be happy to help you with all of your Red Hat training needs. I'm still not seeing anything new in the chat, so I guess we can go ahead and wrap it up here. We
Yeah.
look forward to seeing you all at our next webinar and have a great day.
Thank you, everyone. Have a great day.